Hello maths fans, how's it going? Function notation today, and this is following on from the first introduction to functions. So let's just remind ourselves. A function is a relation between variables that has only one output for any given input. So if I put the number 2 in, I'm going to get only one output. If we have an output variable of f and an input variable of x, then we can use this notation. So this is basically what function notation is. This f of x, we call that, f of x. Now, important to note that that f of x is basically taking x as an input and then applying a function f to that input. It is a bit confusing. It does not mean multiply. Throughout maths, when we see a letter or a number next to brackets, we normally multiply. When we're dealing with functions, it should be very clear that you're labeling a function. So you'll say f of x equals such and such. It does not mean f times x. Get that out of your heads. When we're dealing with functions, it just means apply the function f to the input x. Let's take a very simple function, which we could times by 2 and then add 5. Well, if we're going to write that in function notation, we would write it as f of x equals, well, we times by 2, times x by 2, and then add 5. So that's a very simple bit of function notation there, and that's really all there is to it in some regards. It is just stuff we've already been used to seeing. We've probably seen a lot of y equals 2x plus 5, and it's really, really closely linked. This is always on a coordinate plane, and basically nearly all of the rules that apply to this, how to substitute into that equation, they apply to our functions as well. So they are very, very closely linked. There's nothing to be scared of, just a bit of new notation. And that new notation allows us to sort of write certain things a little bit easier later on. But for the moment, nothing to be scared of. We're just putting f of x, which is apply the function f to the input x. The same as this equation here is multiply x by 2 and add 5, and that gives you the output y. Very, very similar when we're dealing with functions. All right. You have a go. What would the function notation be for this one? If we've got the input x and the output of f comes from dividing x by 5 and then adding 3, what do you think that would look like? Pause now, write down what you think, and here's what I think. So there's the notation. Function f of x is equal to x divided by 5 and then add 3. Pretty straightforward stuff, I would say. This is on a coordinate plane. So if we were considering this on a coordinate plane, on a coordinate grid, then we could say y equals f of x. So again, real close link between these two. Now, we won't always consider it on a coordinate plane, so those functions can apply to all sorts of things. But we could basically treat that the same as the equation y equals x over 5 plus 3 for the purposes of the coordinate. We'll come back to that in a sec. Before we have a look at it in the coordinate grid, let's look at finding the value of this function when we have an input of 30. So let's look at that notation again. We've got f of 30. We've been told the function f is to divide by 5, then add 3. So what's going to happen when I put the input, basically x equals 30? And the way to do this is anytime you see an x in our function, we're going to replace it with brackets and the number that we are inputting. So 30 divided by 5 and then add 3. Well, 30 divided by 5 is 6. 6 add 3 is 9. So I could say that f of 30 equals 9. Simple as that. Substitution, basically. So all you need to recognise is that when that x in there is replaced by 30, I replace the x here with a 30 and calculate it. These are some simple examples. You'll see it builds in complexity. Find the value of f of negative 10. Well, same thing again. We're going to put negative 10. I would get into good habits of putting brackets around any input because it can stop you making mistakes with negatives later on. So negative 10 divided by 5 and then add 3. Well, negative 10 divided by 5, that's negative 2. Negative 2 add 3 is 1. So I could say that f of negative 10 equals 1. And that is substituting there, evaluating when f is, when you've been given some inputs there. Let's go back to that coordinate grid then, and let's actually see that line plotted. So there is y equals f of x, which is basically the same thing as saying y equals x over 5 plus 3. Now, we've just been sort of evaluating when we are given the input here and using the function. We can also use the graph. So if we've got a graph drawn for us, we could answer the question down here. Use the graph to evaluate or find the value of f of 5. Well, let's go from f of 5, and let's remember that this is an input. That 5 is an input. Well, x is the thing that we're inputting, so we're going to go to 5, and then let's read off our graph. So we go up to there, and then we're going to read off the output. So let's draw a line across from there, and you see we're going to get, 4 as the output. So we can use the graph to read off functions as well as substituting into the formula, which can be a little bit handy if we've got a wiggly graph. Moving on. Let's look at a more complicated, a quadratic function here. So we've got g this time. Usually functions will be f if we can use f. If there's multiple functions, you might have f and g and h. And we can use any letter, but those are the ones that you'll see most commonly. So here we go. Let's evaluate when g of 3. So we're going to, again, swap all of these x's for brackets round my number. So there's 3 squared minus 5 lots of brackets, put my input in. There we are. Using BODMAS, I've got to square this first. So 3 squared is 9. So I've got 3 times 9 minus 5 times 3. Sorry, using both things. 3 times 9, I think it's 27. Minus 5 times 3 is minus 15. So I get to 12. And so I could say g of 3 equals 12. Let's just clear that out and put the answer there. The second one, let's input the number negative 10 now, or the value. So 3 brackets negative 10 squared minus 5 brackets negative 10. Minus 10 squared is 100, positive 100. 3 times 100, that's 300. Then we've got minus 5 times minus 10, that's positive 50. And so g of negative 10 equals 350. G minus 10 equals 350. And the last one, we can substitute any values. Fractions are allowed as well. So let's try that one. 3 lots of brackets around the x. There's a half. We'll square it, and then we'll take away 5 lots of brackets around the half. You can, of course, type this straight in a calculator to get these values. We're just doing it by hand for the moment. Half squared is a quarter. 3 times a quarter is 3 quarters. Then minus 5 times a half is minus 5 halves. And then if I want to tidy that up, let's make the bottoms the same because we've got fractions here. So we'll make that 10 over 4. And this one's 3 over 4. 3 quarters minus 10 quarters. Well, 3 minus 10 is negative 7 quarters. Or negative 1 3/4 if you prefer. It equals. So yeah, you can substitute anything in. You can use a calculator. You can do as you like. Let's up the complexity a little bit now. So I'm going to bring in things that aren't just straightforward numbers. We're now going to substitute expressions into our functions. The plan is the same, trust your algebra. We're going to say, what is f of negative x if this is our function? So the function f is to square, then take away 2 lots of the input. So if we're putting negative x in, again, brackets around the thing I'm entering, minus x squared minus 2 lots of minus x. And we just need to simplify this. Well, minus x squared is just x squared. Minus 2 times minus x is plus 2x. And that's it. That's as simple as we can go. Next one, f of 3x. So again, brackets around the thing I'm entering, 3x squared. Minus 2 lots of brackets around the thing I'm entering. And with this one, 3x squared, well, 3x times 3x is 9x squared. And then minus 2 times 3x is minus 6x. Last one here, this one's going to get a little bit complicated because we are multiplying out 2 brackets here. So let's be very careful. X plus 2 squared minus 2 lots of x plus 2. X plus 2 squared, remember that means x plus 2 times x plus 2. So we've got to go x times x times 2, 2 times x, 2 times 2. And when we do that, we're going to get x squared plus 4x plus 4. So that's this part done. Now we're going to go on to the minus 2 times x is minus 2x. And minus 2 times 2 is minus 4. And then we can just tidy all that up and we get x squared plus 4x minus 2x is 2x. So we get x squared plus 2x. And then plus 4 minus 4 cancel out. So there we go. That is what f of x plus 2 equals. Let's just put that nice and clear. Yeah. Okay, so that is substituting all sorts of different things into our functions. I think good idea is for you to have a go at some questions here, and then I will get you all to pause it, and then I'll just fly through the answers very quickly once you've had a go at them. So pause the video now, have a go at those 6 questions, and now here's your answers. So, taking the negative 3, 3 times negative 3 is negative 9. Negative 9 minus 5 is minus 14 for the first one. Substitute the 4 in there to the g. So we're going to do 4 squared is 16 minus 4 plus 1. 16 minus 4 is 12 plus 1 is 13. Then we're going to substitute negative 2 in there. Negative 2 squared is 4 minus 2 is 6 plus 1 is 7. Over to the substituting expressions in there. So we're going to put negative x in here. So we get 3 times negative x is negative 3x. The 5 is a constant, stays the same. Then we've got this one into f of x. So we're still just putting brackets. As you can see here, we'll put brackets and put all of that in for x. And then just multiply out those brackets. 3 times 2x, 3 times 4, 6x plus 12. Take away the 5 and simplify. 6x plus 7. The last one is the tricky one because we've got to multiply out or square an expression with 2 terms. And so we end up with x squared minus 2x plus 1 minus x plus 1. Be careful of that minus times a minus there. And then add 1 and it simplifies to x squared minus 3x plus 3. All of this is hopefully just getting you used to these functions here. Use of that notation, and there's nothing to be scared of. It's all algebra that you've done before. It's just bringing in some new notation. All right, thanks for watching.